So in this video, I want to take a look at this PowerBrite VC-300W Step Up, Step Down Transformer. Something I picked up surplus. I think it's actually the last thing I picked up surplus. It's been with me quite some time, and I decided it's time to do a teardown. So let's jump into the teardown here and see what we've got. Well, let's go ahead and pull the top off and see what we've got. This thing weighs an absolute ton. Extremely heavy. It looked like it had been dropped. I may have captured that bent corner in one of the photos. I've straightened it out as best I can at this point. I may be able to make a bit more progress. It is just, it's got to be all transformer inside. I don't expect to see much else. There are 4 of the screws. And now I won't be able to use the handle to spin it around. Oh, apologies for the noise. Good golly. Not quite the right screwdriver, but for our means, good enough. Let me see if I can get it rotated back around and maybe send it a bit better in the video. Oh, it is heavy. It is heavy, good Lord. Top is off. As I guessed, it is one giant transformer. Wow. That is bigger than I expected. Jeez. Look at that size of that transformer. I'm sitting here in amazement. Let me see if I can find a ruler. Let's get some sizes if we can. Looks like it's in the range of just over 15 centimeters or around 6 inches. It is about 9.5 centimeters by about 3.5 inches. And height-wise, boy, trying to work around lights. I'm not going to get this big old T-square in there. It is just a massive honking transformer. We've got the connections over here that go to the various primaries. Ow. There are, of course, several of them that I guess go to primaries. Wow, that's not a real secure connection. I don't want to muck with it too much. Oh, wow. I will attempt to rotate things up to give you a bit better view. Little piece of tape there. That is a massive transformer. 110 output. The US outlet here is sitting here. The European one is over here. These are both outputs. As we saw in the photos, we can change the input from 110 to 240. With the input being 240, it'll make it a step down to 110. And with the input being 120 or 110, it'll step it up to 220. There's no indication of what kind of, oh man, power this guy's good for. There's no markings on the transformer that gives a hint of how many watts, but I have to believe this is probably the largest I will ever need step up, step down transformer here in the US. This is typical. Looking at the back, it's just 110 volt input. We looked at this in the photo. And then there's 200, 220, and 240, depending on your voltage wherever you are in Europe. And big chunk of the rest of the world. So I guess with this look, let's go in and see if it works and check some voltages. So because we're working around line voltages and potentially stepped up to 240, First thing I'm going to do is I'm going to inspect the test leads just to make sure there's no breaks, no issues in them. I don't want to get shocked because of a test lead that's got a little bit of tape or something residue on it. Always a good idea to inspect your leads from time to time, especially before you start working around high voltages or potentially lethal voltages. 110 will get your attention. 220 will probably kill you. And given the size of this transformer, there's a lot of current available there. And it doesn't take much current at all to really hurt you. So we're on ohms. Looks like I'm in continuity mode, which I don't need to be in. Let's see if I can remember how to turn it off. Now, the first thing I'm going to do is I'm going to get on the input power leads here. And I'm going to turn the switch on. And we do get the mode. Let's get this, there's diode test, auto. That should be pure resistance at this point. So we're jumpered to the 110 volt input. And we're seeing about 1.1 ohms. I'm going to move it up to the 200 volt input. And we see it jump up to 4.9 ohms, which is expected. The 220 volt, actually, was that expected? 1.4 ohms, 1.3 ohms. I'm wondering why the 200, well, I don't really know how this transformer is wound, but I'm going to leave it on the 110 volt input. We can see that the power switch / circuit breaker at least works as a switch. I want to go to volts over here, and we're currently on DC, volts AC. With the power switch off, I'm going to reach through and attempt to plug this in. It is plugged in. I need to be careful here. Hopefully we're still all on camera. So still getting used to the new bench layout. Ooh, squeak, 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 squeak. We're on volts. I'm going to get into here if I can. I can't get a connection that wants to stay. My expectation in this mode is it's going to act as an isolation transformer. Make sure we don't have glare on the meter, and we don't. So my expectation here is it will act like a potentially an isolation transformer. Hold those leads in place and let's apply power. And 4.1 volts AC does not make any sense. The pilot light did come on. That does not make sense. We are on pure AC mode. I'm going to unscrew the fuse here and just take a peek at it. I am plugged in. Wow, that's a big fuse. Fuse looks absolutely fine, but let's throw the meter on it. And we have continuity on the fuse. Let me screw the fuse back in. Jumper link is in the 110 volt. I do not remember on a European outlet which pin is which. Looking at the color coding inside, I still don't have a clue which is which. I'm going to assume these are the 220 outputs. If I can get in there and get a connection. And Let's see. I hear a slight hum. So 243 volts, so it's definitely stepping up. You know, 110, 120 in. I don't know what the exact voltage is here, but we've got a good 242 volts out, which is what I would expect in the US. Oh, it says it's VC-3000W. Is this thing really good for 3,000 watts? Holy moly. So we know it's a step-up transformer. We have output. Like I said, there was a slight bit of hum there in the background. If I now switch the input over to the 240 volt side, and we're only feeding up with 120, I should expect the output voltages to be halved. It should work okay in this condition. So yeah, output voltage halved here. A little more than halved, honestly. So there's 108 out. Before I move the leads, I'm going to come back over here to the 110 volt outlet. And I would expect this to be in the 50 or 60 volt range with the power on if it's stepping down. 54 volts. So we are getting step down action, as we would expect. At about where we expect to be. I'm guessing the incoming line voltage here right now is about 110 and not 120. So let me move this down to the 220 volt input tap. And I would expect that to get us potentially a little closer to 120 here. We'll find out. So 60, and we expect it to be half of what it is. So there's 60, which would give us 120. So not unexpected if I can keep contact. The leads are interfering with each other. I really shouldn't have both hands in here at the same time. I should be able to move this jumper link live with the jumper link out. It should drop off. And at the 200 volt input, I would expect that to jump to 65-ish. And it does. So that says to me all three of the windings for the high voltage input, the 240, the 220, and the 200 are working as expected. Let me unplug the jumper link again. And I'll now put it back into the 110 volt. And I would expect to see 25-ish out. Oh yeah, 120 out. So yeah, that should be 1-to-1. So on the 120 in, we get 120 out, which is what I would have expected. I have no idea why that didn't work the first time. Everything I see here says this is a fully working transformer. So let me go ahead and power it down. I'm going to reach through and unplug it if I can. We are now unplugged and safe. Let's go back to ohms. We should see hopefully the primary on the transformer here. I do need the switch to be on so that we're seeing all the way through to the transformer. We're seeing 0.6 ohms. That makes a lot more sense than what I saw earlier. I don't think I have the power switch on earlier. So we're seeing 0.5, 0.6 ohms. Let's see what the output here is. I'd expect it to be about the same. Or no, okay, yeah, okay, 0.3 makes sense as well. So now what I want to do is I want to look from either side of the incoming transformer to the outside transformer. And so it is not acting as an isolation transformer, which is good to know. And that's because we see continuity through. So I'm assuming when I'm in 110 on the back and 120 or 110 on the front, it's not actually an isolation transformer, which is good to know. I have isolation transformers, so I really don't want to use it as one. I'm going to move the jumper now up to the 240 volt input, and we should see It's winding 0.8 ohms. No isolation action at all, which is good to know. It's just not an isolation transformer. I'm kind of surprised it isn't wired as isolation, but I don't have the schematic in front of me to know. What's it look like on the 220 output side? Wow. Not what I'm expecting. For whatever reason, this should just simply reverse the resistance measurements from what we had before in 0.4 and 0.8. So something is common between the input side and the output side. So it's not isolation, which is fine. Like I say, it's good to know it's not isolation. And I would assume if I get on the ground lug here, and get someplace into the case. So there's the ground lug on the output. I would expect to see very close to a short. Actually the protective ground, the earth ground, I should have said earth before, on the 220. I do see a jumper link that comes down under here. Okay, when I got on the screw, so the chassis is grounded. I must have been, well, now it is, I think I was just on some of the epoxy. This transformer was dipped in some kind of shellac, keep it from humming, and I think I just must not have been getting good contact through, or that's just not a good contact. There we are. Don't have enough hands. Like I say, it's pretty cheap. That feels like it's just wire wrapped under there. This certainly, even though it says CE on the back, I don't think would be CE compliant, honestly, because it's not using proper, none of this earth grounding is done properly. It's just, you know, solder, wrapped around solder and soldered in place. Or wire wrapped around wire, I mean, and soldered in place. So it is what it is. It is a inexpensive, well, this much copper, it wasn't inexpensive. I'll add some labels to this. It's not an isolation transformer. I would expect that to make no difference, and it doesn't. Let me get back on the input side here. I'm curious what happens when I open the, that's what I would have expected. That appears to be wired 1-to-1. So if it's plugged in, it's a potentially dangerous device. You know, making poor assumptions about isolation. It's not galvanically isolated at all, input to output. There's certainly something common between the two. The wiring is not nearly as nice as it should be. You can say there's a strand of wire poking up out of there. I am not going to stress it by testing the circuit breaker. Let me see about rotating this around here, just so you get a view in on the side. So we're coming from the line cord here. European colors. Oh, look at that wire that's been pinched. That wire has been pinched at some point, and the insulation crushed. That's dangerous. I will need to do something with that. Line cord comes directly into, so the blue lead comes directly into the circuit breaker / power switch. I can't tell what lead is the output. Oh yeah, I'm seeing what's tied common here. It's Wow. I mean, it works. I don't like the fact that that lead has been crushed. The insulation is exposed. Ah, this will show up on camera. That's been crushed enough I can actually see copper down through the insulation. That certainly needs to be fixed. And I don't see an easy way to unsolder one side of that or the other. So I will address that. That's rather disappointing, but it's not surprising. I don't know where that got pinched at, probably during assembly. You get what you get with the stuff made in China, obviously. Many people have talked about it. Well, this looks like it'll be a good tool when I need to step up or step down voltage. Really, here in the US, probably only step up. And it says 3,000 watts on the front. Do I trust it? I trust it for what it is. Boy, look at the gauge of that winding in there. It may actually be, I mean, 3,000 watts at 240 volts, it'd be what, 6 amps? Power equals E times I. So 220 volts, or 240 times 6 amps would be approaching 3,000 watts. I think it'd be about 2,800 watts. So maybe, based on the size of that transformer, it's capable of it. Would I bet my life on this thing? No. Could it be useful on the bench? Yes, understanding really the issues with it. Do I truly believe it is CE compliant? I do not. Of course, lots of stuff comes out of China with, quote, CE approval, and it's just something that got silk screened on. I don't think it means anything in the real world, especially when I see how the earth grounding down here is done. The protective earth, I mean, it's not crimped properly. It's just soldered directly on. It just feels like wire jammed up underneath there and screwed in place. What else can I say here? I mean, I keep repeating myself. Understanding what it is, I can use it safely. Would I use it unmonitored? No. But, you know, I think this was the last piece of surplus gear I picked up while I was in Seattle. It's a nice addition to the bench, definitely. So future Neil here, after my little math mess earlier, where I tried to figure out the actual amperage we could draw off the thing, got me wondering if I could find a manual for it someplace out in the world, and did a bit of Googling, and lo and behold, there's actually a couple of manuals here. So let's go ahead and go through what we have. First, we have kind of this whatever it is, you know, PowerBrite, your leader in power solutions, step up, step down transformer. We knew this. It covers 3 different models. It claims it's ISO 9001 certified with the CE logo. Of course it's not. Earlier in, we saw that the protective earth isn't done correctly. In my opinion, it does not meet code. Wasn't using crimp connections. It's just bare wire caught under a screw under one of the mounting parts of the transformer, etc. No, it doesn't meet CE certification. But in all this stuff that you buy, that's imported from a certain part of the world, it rarely does, honestly. So there's a little instruction manual here, and correct input voltage in the back of the transformer may cause permanent damage to your converter and equipment. Okay. Certainly it could output a higher voltage than expected and make a mess. So the first thing we're going to look at here is the mistake on this page in the manual, and maybe you've already spotted it. So familiarize yourself with the features and functions by studying the 2 diagrams below. So the first thing we see is a universal 220 volt input. Okay, that seems kind of odd. This is a female connector. This would mean I need a 220 volt cable or a 240 volt line cord that was male on both ends, and you don't find those. That's really dangerous. So it's called an input here, and of course in the silk screen it's an output. So there's our really fundamental immediate error in the manual, which just gets into these cheap imported and expensive items. Don't trust the manual. They seem to have got this correct on the back, the input voltage selection. which makes sense. Select the correct input voltage according to the country's, voltage before plugging it in. When plugging in multiple items to it, make sure the combined wattage does not exceed the capacity of the transformer. Check your wattage. When selecting input, use the 110 volt outlet only in the front to step down the voltage. When selecting 110, use the 220 outlet only in the front of the unit. So again, this is kind of weird in that it implies you're bringing 220 in here to get, it implies something really odd. And I just can't wrap my head around why this would be both an input and output. It's universal, and then it meets German and European and various other standards for the way the pins are, shaped, etc. on those 220, 240 plugs. But I'm struggling with that being an input. Select the correct input voltage according to the, when selecting input, use the 120 or the 110 volt outlet only in the front to step down the voltage. When selecting use the 220 outlet only in the front of the unit. When selecting input, okay, maybe it makes sense. Connecting it to an outlet, so it only shows the one connection to an AC outlet. It looked like it came with an adapter originally that plugged onto the US connector here, the North American connector, to go into a European German style 220 outlet. I don't have that adapter. We'll look at that a bit later on. Don't overload. Keep well ventilated. How to reach children. Blah 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 blah. And they do make the claim again for this model. It's 3,000 watts, and the fuse is a 30 amp fuse. We did see the fuse was quite a large fuse. So this led to this little spec sheet, which kind of maintains what it said before. So, the VC-3000 watt specification sheet can be used in 110 volt countries and 220 volt countries. It'll convert from 220, 240 to 110, 120, and from, so it'll step up, step down. Free grounded adapter included, $3 value. It's got a circuit breaker, fuse protector. There were spare fuses taped to the backside, and there were 2 of them. But again, if you look close here at the front of the picture, it says output 110 or 220. But then there's a picture of the outlet there saying universal 220 volt input. UK Euro grounded, Italy, Switzerland, India, Australia, US, and Canada. It doesn't make sense to me why that's both an input and an output. It just makes no sense. And this has got to be a translation issue in the manual from, I'm assuming, Chinese to English, whatever. They do say it weighs 37 pounds. I think I can verify that it's very heavy. 3,000 watts, I still really doubt it. I'd have to load test it. I'm not sure I'm willing to load test the thing and burn my house down or full of magic smoke. But anyhow, based on the fact I couldn't do math, that led to, let's find a manual. And finding the manual, we end up right here with confusion. I do not get this, the connector here, the European style connector being an input. It just doesn't make sense. But anyhow, it is what it is. So with all that said, let's jump back into the prime video. Well, if you got this far in the video, I appreciate it. If you enjoyed the video, give me a like. If you're not subscribed and think it's worth it, give me a subscription, and I hope to see you in a future video.